My name is Dimitar. I work at Booking.com as a principal engineer. I'm here today with my colleague Dylan, who is one of the people who worked on the framework we're going to talk to you about today. And the title is Architecting Scalable Python Frameworks for the AI Data Clouds. There is many words, but what we're actually going to talk to you about today is our journey, how we carried out a very large-scale migration, and where this framework fits in. Because what we think is, it's great if you have a lot of data or you want to build AI applications, but we really believe in garbage in, garbage out. So what we have focused on is providing a scalable framework for the number and different roles within the organization we have, that our colleagues can focus on providing quality data. This is what we'll talk to you today about. So without further ado, beyond an introduction of who we are and what we do, I'll try to keep the marketing to a minimum. So we're not going to sell you our company or services. We're going to tell you actually what we're doing in the tech space. We're going to tell you about our platform, which is called BDX. So if BDX slips in, so you got to think about that this is our platform. This is what we've built. It stands for Booking Data Exchange. There's booking in everything that we name, and there's X because it sounds cool. We're also going to talk about the DevEx that we have in the organization. So how this framework helps our colleagues achieve what we need them to do and what they're actually going to do to provide better data for AI downstream. And we're going to give you a bit of overview of what monorepos we have built and how they run. This is going to be quite brief, but if you have questions about that or you're interested in the setup, just let us know. And then in the Q&A session afterwards, we're happy to answer any questions for you. All right. So where do we start? Booking.com is, for all intents and purposes, the premier travel retailer. We have millions of transactions a day with many millions of users across the platform. We have thousands of data practitioners. So these are folks in analytics, data engineers, machine learning engineers, scientists, data scientists, all working with the data, transforming it, building data products or building solutions on top of those. We have many petabytes of data. We're literally not allowed to tell you how many petabytes of data we have, unfortunately, but let's just go with many. I officially have classified us as data hoarders, even though everything is fully compliant. Sure. And we have at least, when we updated this number last week, we had 65,000 tables. So all sorts of different data assets, and now combine this with the 1,000+ data practitioners within the organization across dozens of data teams. This is put together in what we are referring as, the modeling methodology is a data swamp. So trademark. That means that, it's not well structured everywhere. There's structured parts, at the shores of the swamp, but like a lot of it is, there is a lot of garbage. There's places you can really sink in, and there's pure gold. The platform is we're still migrating to our new platform. We're about to wrap this up, but at this point already we have more than 17 million queries a day. This is both services and people querying the platform, and unfortunately, they hit some of our largest tables. Now, where are we right now? Where do we start from? So our legacy platform was Hadoop on-prem. And I mean Hadoop 2, which was reaching end of life with many custom patches to keep things running. It was really big from what we were told. We had 2 data centers across Europe, and they were not even in sync. So people wrote different data in each of the data center, and then we tried to consolidate it all. That was a mess. And the reason for that is it all grew organically over a hackathon, over a weekend, many years ago. So this is really what happened. We've begun to take control of that and create a new platform so that it's more scalable. Now, when we began to build BDX, so the Booking Data Exchange platform, we set a few requirements. For one, we wanted this to be scalable, and scalability in pretty much all dimensions. So we said, okay, obviously storage and compute, Second one is we want the processes to scale. So this is one that's frequently overlooked in our opinion. But we wanted to make sure that we're not sinking our time in managing the platform, but rather things just work, and colleagues just work as well. The other important requirement was, can we have Iceberg support all around? This was early part of the design. We said we would very much like to have Iceberg on S3 on our own buckets, that we have control, that we can plug in different query engines if needed. If someone has a requirement, the data has to be in a different region, that we can easily do that, and that we are more future-proof. We also wanted a different set of tools for different workloads. It's a large organization. We can't really shove a single tool solution down people's throat. We really need to adapt what our colleagues need, but choose a few tool sets we can support. So in our case, we said, all right, let's go with PySpark and dbt. We also wanted really good UI for the whole thing, because we have, again, thousands of data practitioners, so we want folks to have a nice experience if they're just browsing around or using the data. Last but not least, we wanted very tight access control. And we are talking from the very beginning, it was conceived to have object and attribute-based access control system where we can apply row masking, so column masking and row-based policies straight away. So we manage all these 65,000 tables with just a handful of rows that we have built in Immuta, and they're applied on top of Snowflake natively. My colleagues, Jay and Abro, are giving a presentation an hour from now. So if you're interested to see how that works, please join that one. They're going to give you a bit of a more in-depth understanding of why and how. Now, this is an overview of what the platform looks like. It's one of my favorite slides, as an architect. But what we're effectively saying is, all right, we get data in our front-end applications, back-end systems, operational databases, and we get it over to the cloud. We get it over to the analytical platform. We're talking CDC, batches, or streaming jobs as well from various sources. They all land, with some exceptions, in the data lake. This is all Iceberg on S3. For archival purposes, we try not to modify it in transit, so this is raw. Now, and this is where the fun begins. The data that's produced downstream of that matches various maturity lanes as we call them. So we have data warehousing for strictly regulated workloads for finance, for example. We have less managed parts, depending on what the workload is and the requirement within that line of business. And, for Dimitar's experimental exploratory table, you of course go, completely swamp. But so we're not necessarily, if you talk to folks, you can hear many buzzwords about methodologies here or there. We're not strictly adhering to one, not because we don't like them, but because we think that there's different interpretations of how people see, what data mesh is or what lakehouse is. So this is our view. We have taken many advantages, many design points of all of them, but we have built our own. The way this data is consumed downstream of the platform or within the platform as well is there is heavy BI use, and we have a number of geospatial workloads as well, being the premier travel retailer and all. What is interesting though is the heaviest workloads within the organization are actually for machine learning and AI. And Dylan is going to tell us a bit later about what actually those are and why these are so critical for our company, for the organization. The tool sets, as we mentioned, would be Spark and dbt, complemented by Snowpark, and it's all orchestrated by a Astronomer-hosted Airflow. I'm going to hand over to Dylan for the next part.
Yeah, thank you, Dimitar.
Thank you.
So when we're looking at how at Booking people are interacting with BDX, so the Booking Data Exchange, there is a challenge. Because we have thousands of users that are interacting with the data platform, but they are varying technical levels. So on the one hand, we have data scientists that are training models, we have machine learning engineers that are extracting features, data engineers that are transforming data. But on the other hand, we also have many, many data analysts that are doing ad hoc analyses, that are building dashboards. And so we have worked to wrap BDX with a Python SDK to facilitate both the advanced users that need some level of flexibility, and I'll go a little bit into that later, but also the maybe the less advanced users that just want a simple interface to interact with data. So we had a few goals when we were designing BDX SDK. And the first thing is what I was kind of alluding to here, that we want a standardized interface for all of these users. But not only that, we also want to make sure that code is portable between varying contexts. Because in Booking, we're not running only one compute context. We're leveraging Snowflake, we're using Spark. And ideally, code that runs in one place should also be trivial to run in a different place. We also wanted to reduce the amount of boilerplate that users need to deal with. We don't really want users to have to think about creating a Snowflake connection. We want to handle that for them. And crucially, we also wanted to bake some form of schema validation into the platform. And this is something that we had some experience with in the past, where with some kind of data governance related challenges. So let's say that I have a table that I created, and it's a very nice table. People start using this table, building downstream workflows, and then at some point I decide, hey, I want to change this this table now. I'm going to change the table or a column here. I'm going to drop a column there. And I don't know exactly who my users are. What happens then is that downstream things start breaking, and in the end we have an outage that kind of spreads downstream from me. So ideally we have some kind of contract that's between me and my downstream consumer, and some kind of validation that guarantees that that contract is upheld. So to go a little bit into these different compute environments that I mentioned. So at a very high level, we discern between two types of contexts. On the one side, we have we have service contexts. And these are all the automated processes that are reading data and often also producing data back to the platform. On the other side, we have user contexts, which is a human that is interacting with data in one way or another. Maybe it's an analyst that is doing an analysis, maybe it's an engineer that is going to develop a workflow and just needs to test a few things out. And already there is some challenges there, because users, for instance, don't always have access to all of the data, and we might need to do some masking of sensitive data. Like if I rightfully should not have access to all of the PII that is in BDX, that should be shielded from me. So diving a little bit into both of these contexts. On the server side, our general workhorse is Spark. And we also leverage SageMaker for MLOps. SageMaker is an AWS product. On the user side, most users will be interacting with data in a Jupyter notebook, either using Pandas or Spark under the hood. But the MLOps people will also be using SageMaker Interactive, and there will even be some people that are interacting with data locally. Yeah, and so what we really want to do is make sure that switching between these contexts for people is trivial. And so really all that we want to do, or all that we want users to be aware of, is this bit of code. So they should be able to say, hey, I have a context and I know how to build that. And under the hood, this context.build should detect the compute that we're running on, and should return a concrete object that knows how to do all of the things that make sure that whatever they are doing will work. So to give a few examples, this should make sure that all of the auth is taken care of. So this whatever process it is should be able to talk to backend services in our ecosystem. It should be able to fetch secrets from Vault or Secret Store. It should be able to talk with or to fetch data. We have a few types of storage that we support. We're doing Iceberg on S3. We're doing Snowflake native. And also, it should be aware of the environment that it's running in. So if it's a production workflow, of course, if you produce data, this should be made available to downstream workflows. But if we're running an integration environment, we might not want this data to be externally visible, but it might be nice if the user can actually see the data itself to validate that this integration run of the workflow did what it was supposed to do. And so this slide I actually don't really want you to understand, because this is the complexity that we are trying to shield our users from. So in blue, you see some of the things here that I mentioned. There's all these different facets of a context that need to be implemented for it to work. So we have some auth going on, we have some kind of awareness of Snowflake, we have some awareness of Spark. And at the bottom, we have a couple of these concrete implementations of this context. And each of them needs to implement all these different facets. So you see some terms here that I also mentioned, such as SageMaker and the interactive and the workflow contexts. So now that the user has a context, they can get started to interact with data. And here I want to go back a little bit to what I said before about governance and about contracts. So what we're saying in PDX is that, hey, if you produce data that is meant to be consumed by others, then you need to not only give it a name, but you also need to give it a version that corresponds to a schema. So that when I am looking at this data and I want to read it and I want to consume it, that I know what to expect. Also, we are supporting different storage layers, and we also need to point to a specific storage. So in this case, it might be in Snowflake, it might also be a glue table. It's also possible for data to live in multiple places. And so what the SDK will do is it will resolve the data location, it will connect to the meta store, and it will return a data frame to you that you can then do your analysis with. And an interesting challenge that we faced here, maybe you are familiar with it, is that when you are using these different databases side by side, that there are some discrepancies between the types of types that you're going to get returned. So in particular, when you're dealing with structured data, Snowflake might just give you a variant type, whereas an Iceberg on S3 table will give you a very specific structured column. And so we are trying to align these as much as possible so that users don't really have to be aware of which storage they're hitting. They are just can rely on getting the data frame that they're expecting. Yeah, like I said, we also want to provide some flexibility to users that are a bit more advanced. So we're also allowing people to either query directly on the Snowflake connection or to use the Spark connector directly. This mostly comes into play when we're talking about query pushdown. So let's say that I have some Spark process that is working on structured data. Spark might not always realize that it's possible to push this filter to Snowflake. And then what ends up happening is that we are querying the entire table. All of this data goes to Spark, and then we throw most of it away. So a savvy engineer might be able to realize, hey, I can leverage this direct connection to apply this filter to the Snowflake side and reduce a lot of the work that I need to do on the Spark side. Well, after reading, of course, we've done something interesting with the data and we want to write it back. And here again, I need to declare some kind of data asset. I need to have a name, it needs to have a version. But in writing, the SDK takes care of a little ritual that goes a bit beyond just writing the data into a table. So I mentioned that we validate the schema. That's the first thing that happens. We check if the data frame that I'm providing, if that matches the data asset that I've declared. But after writing, we also take a few more steps. One thing is that we send data availability signals to make sure that downstream users of my data are notified and that they can trigger their workflows automatically. But also we do some data validation where we can put alerts on, hey, is there a discrepancy in the number of rows that I am being writing? Or maybe there's a column that is suddenly only nulls. And we also update the meta stores. But with such a big ritual around producing data, that might be a bit too much if I just want to write some table that I just want to use internally, like something that's not for consumption by others. So we also allow users to write intermediate tables that are not governed through these data assets. So on the server side, this means that this is some parquet that's being written to S3. On the personal side, this will be written to a Snowflake database, and this is automatically provisioned for you. When we provision your Snowflake access, you get a schema assigned. And the workflow side of things is also exposed in Snowflake, and this is to debug for the owners of the workflow, so they can figure out, hey, why did my workflow not act exactly as I expected? I can check the intermediate table myself in Snowflake to see what's going on. And here too, the code to write intermediate tables is fully portable. So it doesn't matter, it will detect itself if it's in a service workspace or in a personal workspace. And this portability really comes into play when we're working with SageMaker. So this is the MLOps flows. A machine learning engineer might start out in a Jupyter notebook, query some data, figure out what to use, then move to SageMaker Studio, which is an interactive environment, and then finally move to put this in production in a SageMaker pipeline. And throughout all these hops, the code stays the same. And of course, the contexts also make sure that SageMaker has pre-provisioned Snowflake access. As Dimitar mentioned, we're also using Snowpark. We're mostly using this for heavy-duty workloads, mostly the multi-terabyte to petabyte-sized stuff. This is mostly because we don't want to move this data outside of Snowflake into Spark, but we would rather keep this within Snowflake. And this is mostly for the ranking and for the recommendation type of workloads. So let's say that for some reason you're interested in staying in a hotel in San Francisco around this time of year near the Moscone Center. I don't know why. This is the type of recommendations that we might be able to provide using these types of workloads. This requires some small code changes though, mostly to replace the Spark data frame with a Snowpark data frame. We're also still improving our support of this still.
So, talking about monorepos, or at least what we're calling monorepos, you can call us Alan, on that if you don't think these are pure monorepos in your mind. The first one is what we're calling the booking data or BackNG data. So this is the PySpark monorepo. It's a whole framework on top of the framework on top of the framework. So what it gives you is a process where people focus on producing data, reading data, and the CI pipeline and the framework make sure that you can't commit many mistakes. That is the build process, so you can reference easily already created data assets. You can use them as your dependencies, and any dependence any output that you create, and it's a dependency for someone else downstream, would be checked that you haven't broken that interaction, that you haven't broken that contract, that it all works. So the CI pipeline makes sure most of that works. If you're interested how we're orchestrating that, so for any fans of Bezo, it's Bezo. Whoever doesn't like Bezo, like me, it's Bezo. But we're trying to figure out if there is a better way to orchestrate it all. Now, the other monorepo is the data warehousing monorepo. So that is the DBT one, where we have all the projects, or as in most projects, that are focusing on the well-modeled data within the organization. So this is dimensional modeling, data vault. We're talking about creating semantic layer, actually building metrics definitions, things like that. The CI pipeline there is very different than the PySpark one. The CI pipeline takes care validating data, naming convention, everything else that comes with the stricter modeling. Anybody familiar with data warehousing? Okay, all right, so you know what we're talking about, but imagine that this is checked on pre-commit or during build, so committing a fault over time as we have added many rooms becomes much harder. And it's not because we really want to be, hard on people about that, but it's because we want their data to be easily consumable downstream. Now, the third monorepo is the biggest by number of entries we have, which is what we're calling the BDX workflows. So this is the hybrid Spark and DBT. It effectively is the catch-all for everything else. This monorepo is the catch-all, and we have both our in-house DBT extensions and our PySpark framework, so booking SDK. We have what we're calling a worry-free CI pipeline that does a bunch of validation, build time, and more importantly, it actually provisions resources for your workflow. That is, It's going to make sure compute is available. It's going to make sure the downstream systems are ready to receive your signals, that your workflow is going to wake up at the right signals and trigger it at the right time. It's going to provision or request at least access for your workflow, so you don't have to think about that. You declare what your dependencies are, you declare what you're producing, you declare what compute you need in which platform or platforms, and then the CA pipeline is going to interact and make sure all of that is actually saying it's going to work. All right, so some upcoming work. First, in terms of the SDK and the DevEx enhancements going forward, we want to focus on leveraging some of the native Iceberg capabilities in the SDK that we are absolutely not doing right now. For one, we're not using branching. What we want to do, for example, is we would like at the beginning of a job to branch right into the branch, run validation of that branch and merge it into the main, and we want this to be automated with a simple flag or like even a default option. So if I'm producing Dimitar's test pipeline, I probably don't care about that. But if I'm doing this in production for a mission critical workload, I probably want to do these checks. The other thing that we would like to do is you allow for configuration of partitioning and clustering more natively within the framework. So right now it assumes certain configuration for you. We want to give users more option, and we want to leverage more of that based on what you can do with Snowflake and Iceberg. And to the question earlier, the experience with DBT and PySpark is somewhat divergent. We want to make it similar, but not in a way that takes, the Python-ness out of Python or the DBT-ness out of DBT. But for example, there's different expectations right now for users who use either one or the other framework. As much as possible, we want to remove those so that okay, my workflow will always be provisioned. I will interact with it the same way, or I would expect the same requirements in terms of data quality, data validation, everything, because it will be wired up for me. So I can just focus mostly on describing what my data would be like and making sure that it runs.